Hello, my name is Ed Cunnie. I am the Regional Manager with AEMC Instruments. Today we're going to talk about our latest model 200 amp micro-ohmmeter, model 6290. And what we have here is a device that can measure resistance down to 0.1 microohms, clear up to 20 milliohms, which gives us a good broad spectrum of measurements. The resolution is unprecedented at 0.1 microohms. Accuracy, heretofore not available, is 0.5% of reading, not of scale, of reading, which is a significant difference. Also, we have an analog bar graph which gives us a full indication of what the current is being applied to the test specimen. Okay? And it can store up to 200 readings, and we can actually download that through a USB port. Okay? It has a tabular printout which will record our test up to, again, 200 test results, test specimens. Comes in a rugged, weatherproof case, IP54, and we have a combination of a test equipment box, and we have our accessories, our cables that we apply and connect to our test specimens. Now, taking a closer look at the instrument, we see first of all, a very simple layout that is ideal for ergonomics and customer end use. Okay? Starting with the input power, because we have such large wattage, watt seconds, it requires external power. Okay? Has fuse protection. Here's your USB port for downloading your tabular listing of your test experiments. Here's your vernier control, which allows us to control the output, and we have a gas gauge, if you will, that will show the relative position of the current, output current, and we will have a digital display, we'll show you that in a minute, that will read the date, time stamp of the test, and the actual resistance value and the current being applied. We start a test and we stop a test, and to put it in memory we hit the save button before we stop the test. And we do have a selection right up front. Do we want to go with 100 amps or 200 amps? We have that selector switch, and then that'll allow us to read higher end readings of 20 milliamps versus 2 milliamps. Our input lugs, these are our injection lugs, which we send the current through the test specimen or test device, back and return path, and then the Kelvin clips, which give us unprecedented accuracy, eliminating the resistance in our test cables because we are measuring right at the point of contact. And because in some certain conditions in substations where you might have high induced voltages, you are allowed to ground out your test specimen. So that's an additional feature. For example, here would be a test we would conduct. We want to test the crimp at this point around the conductor wire. We would travel back to an area where we could access the conductor wire itself and go to the end of the lug itself. And now in this case we're going to pass current through the positive, out and return through the negative, and we're going to read across the device the potential, and that will tell us what the resistance is. We will calculate it at this point of the crimp. Now what we have here is a 1 milliohm test standard that we're going to use to indicate on the device and guarantee that it is functioning properly. We have our test leads coming back and being connected to our test device. Okay, first what we do is we make sure we have all our connections properly. These are all color coded. We know that we have our injection terminal, our return path, and then our two potential terminals hooked up properly. Again, they're color coded to make it easy and ergonomic. In this case we're not using the grounding. Then we go to our on switch and turn the device on. It goes through a self-test procedure, checks itself out, and it tells us that we have a previous setting that we left in the device, so we have to turn this down to 0 to start our new test. Okay? So now we get the indication it is ready to go. What I do is I say start. It tells me what test increment we are in the process of making because we stored 98 previous tests in here. So it tells us the next test is going to be test number 99. We have a clock here that tells us how long we are applying current through the test specimen, and we have a date and time stamp. And we are now going to start to increase the current, and you'll see the gas gauge effectively go up, and our test specimen, we will put full 200 volts, and it tells us that it is a 1 milliohm, and that's our test specimen rating. It tells us what our current is, and it tells us how long we have had the current applied to the device. And again, we have date and time stamp. And that is how simple and easy it is to do this test. And I'm going to turn it off now. Oh, prior to doing that, while I have it out, I should hit save, and that will increment our test and store it in our memory for later downloading out of our USB port to our DataV software package. Now, these are the auxiliary components that come in the kit form, starting with the high current connections which go to our test specimen, and these are the classic Kelvin connections, whereby we have the injection connections, and then we also have the voltage connections. So we inject on this side and we sense the voltage here, and then of course we have our mating return path for the high current, and we have the other half of the potential monitoring. Now, if we know what the current is going through the test specimen, and we know what the voltage across the junction is, we then calculate the resistance. And because we have brought the sensing leads right out to the point of contact, it eliminates the resistance of the leads themselves. We have the power cord, and in the case of high inductive voltages, we have a grounding strap that can be put on the test specimen and brought over to the test box. And of course we have a USB port for downloading and the cable. Now, who would use a device like this? Well, one of the key users obviously is utilities. Substation engineers for testing relays, contactors, what have you. T&D engineers out in the field where we are passing along high energy values, where a little bit of resistance goes a very long way, creating heat and generating hazardous situations. Next, we have for relays, circuit breakers, bus bars, and connections. Disconnects and bonding in general test. Next, we have the railroad industry also would use a device like this for track bonding and welding, checking their weld points, and also grounding, because they have very heavy needs and requirements for grounding, especially in electrified train systems. Last but not least, we have aircraft, for example, for checking fuselage fasteners, weld points, junctions and connections, and tube connections for hydraulic and fuel. So to summarize, we find out we have a device that is now fully adjustable from 10 to 200 amps, unprecedented accuracy, down to 0.1 microohm for resolution. We have USB connection now with the DataV software package for a tighter listing of our readings, and we have long leads availability up to 50 feet. This concludes our test and experiment and the explanation of the device. I want to thank you for your time and attention. Again, my name is Ed Cunnie with AEMC Instruments.